This is a beta, so I am going to actually show a new feature of 4.2, which will be released very, very soon. But actually, I'm going to take a step back and kind of show you the power of vCluster platform from the perspective of somebody in my role, somebody that does what I do day to day. I give many, many demos every day, and I need a way to spin up dynamic demo environments that have different tools and integrations showing different features. So I actually leverage vCluster and the vCluster platform itself to automate the process of creating demo environments. So once again, there's kind of two components of our commercial offering. There's the vCluster platform that you see. It's more than just a UI. There's custom resource definitions for everything you see in the UI, but then also there's the vCluster distribution itself, and we have a pro version of that, or pro features, I should say, for that distribution. So yes, there is an open source version of vClusters for running individual instances of vClusters. How you manage those vCluster instances is completely up to you and on you, unless you buy the vCluster platform from Loft. It makes it a lot easier to manage many, many vCluster instances across many, many host clusters. So taking a step back, this is actually a demo environment that I created with another vCluster platform instance, actually. And what happens when I create a vCluster demo environment is it actually creates a copy of a GitHub repository template, and then uses that GitHub repository that it created, actually using Crossplane in the parent vCluster. So I have Crossplane running in the parent vCluster and vCluster platform instance that I've created a custom Crossplane definition, and then a CRD that's based on that definition that allows me to create these repos. The nice part of that is that it's synced from this vCluster where this platform instance is running to that other, the host vCluster where Crossplane is running. And that way, if I delete this vCluster either on purpose or automatically, then it automatically cleans up those Crossplane resources for me as well. So for example, here is that virtual cluster. Basically, this is kind of the state that I want that vCluster platform environment to be in. So underneath, I have a lot of examples here, but the core of it is this vCluster GitOps. So within the vCluster GitOps, I have a bunch of virtual cluster templates that I'll show you those in the UI, a little bit more exciting in the UI, but basically, again, everything in the vCluster is managed as a custom resource definition. So then I can leverage Argo CD, for example, with an Argo CD application to deploy all of these resources, these vCluster platform specific resources to the namespace in the vCluster where the vCluster platform is running. Typically, you would install vCluster platform in a physical cluster, GKE or AKS or EKS or bare metal or whatever it might be. But for demo purposes, it's really nice to be able to spin up a vCluster and install whatever I want. Taking a step back, I'll create a demo environment. So this is, I call it my demo generator environment. And once again, running in vCluster, I mentioned that it has Crossplane installed. So you can see those custom resources that I mentioned before. So I have this demo repository custom resource, and that's going to be part of kind of my template for creating demo environments to create that copy of that repository. So I don't have to modify the parent repository, that template. I can make whatever changes after this is created. And again, it gets cleaned up for me automatically, so I don't have to worry about cleaning things up for myself. You obviously can apply the same concept to pretty much any use case that you can think of. So if we go back over here, I'm going to go ahead and create a new virtual cluster. So once again, I've actually created a virtual cluster platform demo template. So let's just take a look at that template real quick before. So here's that template, and we have different versions. So I actually have 4.11, for example, is the latest release, but I also have a beta version so I can spin up the latest and greatest features to show off. For example, some cost tools that we've just made part of the 4.2 release. Here you can see this is my demo custom resource. So we have a ability, this is actually a pro distro feature that allows you to sync very easily, sync custom resources from the vCluster to the host cluster. So in this case, it's going to sync this demo repositories demo loft.sh resource. So any of those type of resources that I create inside of this vCluster will actually be synced to the host and then serviced by something running on the host. In this case, it's actually Crossplane. The nice thing about this as well is there's no cluster admin configuration, so no cluster access rules you have to configure to be able to create this CRD in the vCluster or to pull it from the host. And that's another thing also, that it dynamically pulls the CRD from the host automatically. So if you don't, you have to ensure that you have whatever operator or controller that uses the CRD running on the host, so that CRD is available. And you don't have to actually manually install that CRD into the vCluster. The vCluster actually does that for you based on this configuration. Also, we leverage sleep mode. So this is a very important feature for our customers, and something that we talk about quite a bit with prospects is sleep mode. And basically what that does is allows you to set a specific amount of time where if that vCluster is inactive, meaning there's no Kubernetes API access and no ingress activity into that vCluster for the specified amount of time, then the platform will scale down the workload of that vCluster to 0 pods and the control plane itself to 0 pods. So basically the platform acts as a proxy to the control planes for access, but also for the sleep feature. And so it's able to basically automatically scale down a vCluster. And then in the case of like, you know, a cloud cluster like EKS or AKS, you might be using Carpenter or some other autoscaler to automatically scale down nodes to reduce cost. Or even in bare metal, vCluster is extremely popular for bare metal use cases where they don't want to manage many bare metal clusters. Rather, they manage fewer, larger bare metal clusters to make management easier. For them, they basically allow that capacity to then reuse by other workloads. Maybe they have batch jobs that run at night, so they want all the vClusters using by developers during the day to go to sleep at night. So there's lots of different use cases for that sleep mode. And in addition to that, we actually also have auto delete. So auto delete, actually, after something's been asleep for a certain amount of time, if there's no additional activity for the specified amount of time, then the platform will actually delete that vCluster and its workload. So this is just especially nice for ephemeral use cases, developer use cases, and demo environments. I may forget to delete a demo environment because I may spin up, you know, a dozen in a week and I just forget. But eventually it'll go to sleep. So the cost is almost nothing, a little bit for storage maybe, but no CPU or memory being used by that vCluster. And then after a certain amount of time, if I continue to forget about it and never wake it up, then the platform would just automatically delete that for me, clean up my mess. So I don't have to clean it up myself. So I'm just going to pause for a second and just see if there's any questions so far. If there aren't, that's fine. But I like to give people a chance so they don't feel like they're interrupting me.
Nothing so far, but seems pretty cool. It's a little bit. It's way more advanced. Oh, here we go. Do you see it up there? You may read it to you.
Oh, you can read it to me. I don't have it open.
So, is there an option for on-demand sleep mode, or is it only managed automatically? So I guess that, like, could you update it?
Yes, actually, that great question. So I actually have an example of that over this template in the actual demo environment, because sleep mode is an important feature to demo. But if we look at the configuration, well, we can see it here, and we can also see it here in a more UI way. But basically, there's also kind of a cron-based schedule for wake up and sleep. So you can automatically, I don't have it set for sleep to automatically put it to sleep. That's only based on inactivity. But I do actually, for demo purposes, what I'm doing is actually waking this up every hour from 8 until 5 p.m. Based on my time zone. I'm on the East Coast, so New York. I don't live in New York, by the way, but that's my time zone. And so every hour it's going to wake it up, but actually the sleep's set to 25 minutes. So the idea is that typically I will have calls at the top of the hour, not always, but typically. And so at the top of the hour, everything's awake. And then I can demo different features of the virtual clusters and templates, etc. And then, you know, as I go through the demo, for the vClusters that I haven't been interacting with either the API server of that vCluster or through Ingress, they will then automatically all go to sleep 25 minutes into my demo, which is a nice way to kind of demonstrate the value of sleep mode. Obviously, those configurations and settings will be different for different use cases. The nice thing about templates, as you see here, is that basically I'm applying this to all the vCluster instances that are created from this template. Further, I'm actually leverage this as a default template. So if we go and I'm kind of jumping around here, but if we go and look at this project, so basically a project is just kind of a construct, kind of like a folder almost, where you can manage access to different components that the platform manages. Those include users and teams. Like, so what teams or users have access to this project? Obviously an important important first step. Also, then assigning roles to those users and teams. So here I've assigned the project user role to the API framework project. So that means anybody that's in this API framework team that can then further be mapped to some kind of external SSO group, like an LDAP group or an Active Directory group. They're only going to have project user, meaning they can come into this project and then leverage any of the templates that we kind of just took a quick look at a virtual cluster template. But here we can specify what virtual cluster templates are available to them. And then actually also require that they use a virtual cluster template, because we don't want it. You briefly saw that configuration for a vCluster. There was much more to it than just sleep mode. There's a lot that can possibly go into configuring a virtual cluster, and you don't necessarily want all your users to have to deal with that, or even maybe don't want them to be able to configure certain things a certain way. So that's why templates are very nice. And then you can actually also specify a default template. And that template that had the sleep configured the way that I wanted, that is my default template. So if I just go and really quickly want to create a vCluster in this project, going to automatically use this default template by default. Also, in addition to that, inside the project, since we're here, let's just finish giving a quick review of the project. There's also this concept of allowed clusters. Allowed clusters are basically the host clusters where you are going to deploy vCluster instances. So it's very important to be able to control that at the project level. So if you have ephemeral developer type vCluster use case, you're probably going to tie that down to one or more developer clusters, not your production clusters. Then you might have a project that, like for a production type vCluster platform project that you're actually deploying to production clusters, and you wouldn't want to necessarily give access to just all your developers or all your users to that particular project, and you would then map that to your production clusters. So again, in this demo, it's pretty simple demo. In some cases, more complex than others, obviously, but I only have the one host cluster. But if I had multiple, I could select multiple and manage what host clusters are available to deploy to. The nice thing about that too is that the vCluster platform abstracts that away from the actual tenant, the actual user. They don't have direct access to that host cluster. So they can't actually interact with anything in that host cluster other than their vCluster or vClusters that they create. Also, we have this concept of project quotas that goes well above and beyond a namespace quota. So with a project quota, I can define pretty much all the same thing, and even things like active virtual cluster instances here. So in this case, I'm actually saying this project is not allowed to have any more than 15 active virtual cluster instances. And remember, I showed you sleep mode. So that's nice, because if there's certain vCluster instances that sleep at night or more during the day, then you can still have additional vCluster instances that are active. So as soon as one goes to sleep, somebody can create another one, but you're always going to be limited to the number of active instances. You can further, so I could do CPU and memory, and that's across all vCluster instances, across all namespaces, and across all host clusters that are configured to have access from this project. So I'm going to go ahead and remove that, but then you can further limit that by the individual user or name, the user or team rather. So for example, I've limited the number of virtual cluster instances at the user level, or at the team level rather. So here you can see that all of these 4 different users, they've each used 1, and it can only create 3 more, for example. And then she won't be able to create any more vCluster instances inside this project. So not one user uses up all this resource. We have some interesting integrations, which we probably won't dive into today, but that gives you a quick kind of overview and understanding of the project and the usefulness and why we have projects inside of the vCluster platform. So if I go back over to our demo generator environment, I'm actually going to create another demo environment. So here I showed you that template. Another nice part of a template is parameters. So you can have parameters that will allow you to inject values in different parts of that template based on the selected value of that parameter in the form to create a template, a vCluster rather. Also, everything that you see in the UI is also available to use from our CLI and also our virtual cluster instance CRD. So you can actually configure a plain Kubernetes manifest that is our custom resource for a virtual cluster instance with all this information as well. So it gives you lots of flexibility and ways to dynamically or create vCluster instances with whatever existing workflows you have. So here actually I have some checkboxes where I actually integrate with Argo CD to first automatically add this vCluster to Argo CD as a cluster target. as something to deploy to, a Kubernetes cluster to deploy to. And that happens through that platform integration that I mentioned briefly in the project overview. Basically, the platform is able, as long as the Argo CD is running somewhere that the platform has access to, either one of the clusters that is connected to the vCluster platform, or in a vCluster itself that's being managed by the vCluster platform, it can actually create a special secret. Argo CD calls it the cluster secret. And so it creates a Argo CD cluster secret with the correct information to connect to that vCluster. And then in addition to that, it'll also gives you the ability to inject labels. So you can have labels that are part of your virtual cluster template, and then you can inject those labels into the cluster secret. And this is maybe a slightly more advanced use case, but I'm actually leveraging a Argo CD application set that's using the cluster generator against the labels. So basically, let's say we have a nice external secrets operator integration. So I'm going to go ahead and click that and say, let's install the external secrets operator as part of this demo environment. And maybe I'll even call it ESO demo. Then also I've got additional parameters. Yeah, go ahead, Mike.
Say, unless you like stare at this all the time too, the interesting thing is like your base cluster where you're deploying all this stuff is 4.00, and you're installing a newer version of something to test. So like if you want to test a new version of vCluster platform, you can do that easily, or something outside of vCluster, like you can deploy new versions of Kubernetes and stuff like that too.
100%. Right? Like, yes. Fantastic tool for that. And actually, you could actually, so one of the things I parameterize and is typically something I demo is that you can actually run different versions of Kubernetes itself in the vCluster that's running on the host cluster. So I had 1.30.5 selected by default, but I'm going to go ahead and go with 1.31.1 in this case. I don't have a specific reason to demo, but if I did, I could easily do that. But from a test perspective, this is awesome. If you're testing things that are specific to different API versions, you can actually spin up a vCluster or multiple vCluster instances in parallel and test like an operator or controller, maybe you're building yourself, across multiple versions of Kubernetes in parallel. So I'm going to go ahead and click create, because it does take a minute, and plus with extra things being installed, it can take a little bit longer. But now actually, if we go and look at the Argo CD, well, we'll wait till this gets up and running. But yeah, let's go look at this template once again. Here is our vCluster platform demo template. So lots of stuff going on. The one thing I did mention is those labels. But maybe an easier place to look at this is in GitHub. So this template actually is in a parent kind of repository. And so if we go look at our GitOps and we go look at our template, so here's our demo template. And so we're actually injecting those parameter values. So here we're injecting those parameter values I just showed you, Governo, ESO, Vault, as labels on the virtual cluster instance itself. The platform will then, if you have Argo CD integration, as you can see here, I'm also have Argo CD integration where I'm going to automatically add this instance to Argo CD. So as soon as this virtual cluster instance is up and running, it's going to automatically get added to Argo CD. And then that cluster secret that's created for Argo CD will have these labels be part of that. And we will see that the kernel, the ESO label rather, has been set to true, both on that virtual cluster instance CRD, but also in that Argo CD cluster secret. So if we go back over here and we take a look at our virtual cluster instance, it's up and running, probably still installing stuff because it installs quite a few things. But if we actually look at the YAML, so here's our virtual cluster instance CRD that the Loft, that the vCluster platform provides. Again, a pro feature only. You can't get this with open source. Here are the actual parameters that I supplied. So remember, I mentioned you could just as easily, I could have created this with kubectl, from the command line if I wanted, because I can use this custom resource directly to create vCluster instances. And then up here, you'll see where it actually injected those labels and the values of those. So here we have ESO is true. Now, if we actually go and look where this actual vCluster is running on the host, I'm admin, so I actually have access. So I can actually go to the namespace where this vCluster instance is running. Here I can see the control plane. I can see the different things that are starting to be installed here. That was the vCluster platform. Argo CD is now being installed. But if I go up a step, if I go up to Argo CD, so here's the Argo CD that's running on the host cluster. And I can go to the cluster secrets, or the secrets rather, yeah. And we'll see that we have 1, let's see, on page 2, rather, let's see, ESO demo. So here, if we show this, and so we have the information to connect to that vCluster instance from Argo CD, but we also have those labels I mentioned. And here, our ESO label is set to true. So that's actually going to trigger the creation of an application set, an application from an application set based on that value. So now if we actually go and look at Argo CD that's attached to this vCluster instance, and we will see that it, oh no, actually let's see.
And your local cluster to GKE instance, right?
Yeah, so that's another interesting thing too. You could, like, for example, one of the things you'll notice in this sync configurations that I'm syncing ingress resources as well. That's a common, so it's very straightforward. Just I'm saying, hey, sync ingress resources from the vCluster to host, enable true. So then what happens is it's actually going to leverage the ingress controller running on the host. But in this case, actually, I don't have an ingress controller running here either. So I've actually synced not only this vCluster to sync ingress resources, but also the vCluster where this is running, which actually happens to be on Loft.rocks. And this is the actual ingress controller on a GK cluster that services those ingresses. So actually, I don't even know if I can find the namespace because platform staging. So here's the beta. So like that ingress from that vCluster is actually synced here. You can see all my Argo CD ingresses, but all of my ingresses for all my demo environments actually end up on this GK cluster. That can be 1, 2, 3 vCluster or instances up or down, depending on how you look at it. But the one single host cluster with one Nginx in high availability, so as 3 pods. If I was to install that ingress Nginx controller on every single vCluster, that would be hundreds of additional pods running, as opposed to sharing that one ingress Nginx controller that then allows me to obviously save a lot more money. But I know, we kind of are running a little bit out of time, and we want to leave some time for questions. I do now want to highlight our new cost control dashboard that is being released with 4.2. The one component that is still coming later is actually sharing things like controllers and operators from the host and how you save with that or are not saving. The idea of the cost dashboard is to show you different things like sleep mode or reducing the number of physical clusters to increase cost savings. So over here, we have our sleep mode. We can see that we're already saved roughly $57 today on just using sleep mode. And again, this is a simple demo environment. Imagine this across dozens of host clusters and hundreds, if not thousands, of vCluster instances. And those savings can add up quite a bit. We actually worked with a large insurance company that's now a customer very closely around sleep mode for their developer environments. And they saw close to slightly over 65% savings for a very, very big budget for the development environments.
You change that date range, make those numbers go up.
Yeah, so this demo environment with this cost information has only been running for almost 2 weeks now. But if we go and pick everything, we can see that in less than 2 weeks, we've basically saved almost $1,000. Again, in a very small. I only have the one host cluster. If I had multiple host clusters with dozens of vCluster instances each, obviously you get the idea. But also can then show you quickly like when something's going wrong, like why didn't I save as much on sleep that day? And you can kind of dive into that and dive into the individual vCluster instances to see which ones are using sleep mode more effectively or aren't using it at all. Actually, in this case, I do have one. Like I also, in addition to like running Argo CD on a host cluster, you can actually run Argo CD inside of vCluster and then use that Argo CD instance for your vCluster instances. And you'll notice also, by the way, all my vCluster instances are now sleeping because 25 minutes past the hour, they were automatically woken up with cron at the top of the hour. And it's been over 25 minutes. So now they're sleeping. If I go in here and look at it and actually go to the host cluster where it's running, you'll see 0 pods running. And that's exactly what sleep mode does and helps you reduce costs. So I don't know. I mean, I know that was a little bit of a whirlwind and a little bit all over the place, but I do like to show off how I build demo environments, but also obviously it's important to understand that vCluster platform can save you a lot of money.
Yeah, so if you end up talking to like sales and like get a sales demo, you're going to see Kurt and he's going to show you like based on your logo and all that stuff and spin one of these up for you using the same stuff, right? Like And
Yeah,
you're showing
actually, if we go back, we now should have this one up and running. I should have done a different logo. Maybe let's see. Here we go. Okay, and now you can see also we're leveraging our own OIDC to log in. So that's single sign-on, and we actually support single sign-on with multiple providers as well. They'd all show up there as separate links to log into. And now here is our vCluster demo environment that I just created. Took a few minutes, installed quite a few tools. I have Crossplane running here as well for different use cases. It installed external secrets operator. So if we go and actually look at the cluster, this cluster is actually a vCluster, right? But I configured it to install the external secrets operator. So here is external secrets operator running based on that configuration I showed you earlier. It's got Argo CD. So it's really powerful to automatically like install stuff and have that be part of a template. So that your developers or whatever your use case is, whatever tools, whatever things you need to be in place when that vCluster is created is very easy to do with virtual cluster templates.
I know it went quick, but like you've showed 3 different versions of vCluster platform running, and you've shown like probably at least 2 different versions of Kubernetes running, all on the same GKE cluster, which is pretty cool. And this is basically like if you're installing your own SaaS, this is kind of what you just showed us here too, kind of, right? Like if someone has their own SaaS and they want to stand up everything.
That's a very common production use case, is actually leveraging vCluster for SaaS type workloads. Because again, it gives you that isolation that you need from API, from a control plane perspective. It's lightweight, obviously much easier to manage and lighter weight than spinning up physical clusters that can get really expensive really fast.
Well, awesome. Yeah, if you have any questions, let us know on here. You can ask. We'll wait a couple minutes, and then if you have any questions, you can ask in here. But also, you can join Slack and ask in there. But we'll be back in January too. So we'll be out for the next couple of weeks, holiday and time off, and then in January, probably bring Kurt back in. Okay, here's a question: did you say the UI was only available with the commercial offering? So your sales,
that's correct. Well, we do have a 14-day free trial, so anybody can install it and use it for all the features for 14 days. But yeah, that's part of our, obviously we also developed open source vCluster. There is a little bit of community, that has made some community contributions to vCluster, but for the most part, it's our engineers that develop, 99% of vCluster open source, and obviously they need to eat, right?
Yeah. And you can install. So we have vCluster.cloud now too, which will let you just spin up, and like if you don't want to install this in your and if you don't want to install this in your Kubernetes cluster, you can use that to just kind of get started quickly. vCluster.cloud. I'll put it in the. Oh, you can show it, yeah. Which is kind of newer, right? Like this is still beta, right? Like so, if you just want to try to create something and play around with it without installing it locally, you still need to connect a cluster in. Like it doesn't give you cloud hardware and like that. You would just import a cluster in. But yeah, another question is, what state database is used for the virtual cluster? Does it create its own etcd instance? Well, the default SQLite, right? But you can do a bunch of different things. I'll give it to you, Kurt.
Yeah, for sure. Actually, so I always use our embedded etcd. It's a pro feature, but it's a fully managed embedded etcd. So first and foremost, it works better with larger workloads. We have seen issues with customers and in open source with the SQLite solution for larger workloads running inside your vCluster. And sometimes the SQLite can get bogged down quite a bit. So embedded etcd helps with that. But also the really nice thing also about it is that it makes it really easy to create a highly available virtual cluster instance control plane just by increasing the replicas of that vCluster pod. So for example, I could go into this Argo CD. It is a template. So if I go to the repository that was created for that template, you see I've got a demo app repository now, so I can make changes and it's only going to affect this one demo environment. Nice, right? But here's my Argo CD vCluster template. I can modify it and then change the replicas to 3. Let's see, where's that going to be at? Up here. So here is that's Argo CD. Here's our control plane. Actually, let's go look at our docs. I don't remember where that is. Mike, do you remember where that is? I think it's under control plane, probably stateful set replicas. Is that right? No.
But I'm just seeing it through template. But while you're doing that, the other answers too is you can, so SQLite probably if you're just installing like a single virtual cluster and it's just like a preview environment, or like a developer just doing like basic, like a single application that's not going to use up a lot of space or something in the database. Like you're not installing like 50 different things, a bunch of TRDs and stuff like that. But then also we have the external database stuff too that you can connect to now with the newer version, to where like if you're already running your own, MySQL or something like that, or you have like a cloud. Right now, I think it's just MySQL. If you have a cloud database that you're using for everything that you're backing up and replicating and all that, you can connect these virtual clusters into that as well. Which we just did a blog, we'll have video and stuff about that coming soon. The external database connector. Yeah, so Kurt's showing you like
Okay.
basically the vCluster YAML is what you're going to use for all the templating and stuff, and we have all that stuff documented out on our. Let me post some actual links to docs and stuff like that while you're doing this, so people can see.
Oh wait, I need to go over one. Underneath backing store, this is control plane.
Live updates.
Yeah, we'll see if this works. But yeah, so I'm not creating a pull request though, which I should. I should create a PR, another branch, test it. I'm going hardcore here and just committing it directly to main. But that should then trigger Argo CD that we actually have over in this other project. So we have an Argo CD that's dedicated to this vCluster demo environment. By the way, we also allow you to integrate single sign-on from the vCluster platform with Argo CD. So if you want to create either throwaway or you're not using SSO today with Argo CD, it's very easy to leverage whatever SSO you've integrated with the platform. And here we have it already synced. So it's already synced a few seconds ago. So it should have already updated that template. And now if we go back and look at our templates, I guess I did it right because it would have failed if I hadn't. If we look at the Argo CD template, we'll see that sure enough, here we have our stateful set and we have high availability set to 3 because we're using that embedded etcd. Otherwise, it would not have worked. Another type of backing store that's only available with Pro as well is external database for like plain vanilla Kubernetes, that is. So you can actually leverage, for example, like a managed MySQL database like RDS in AWS. And actually there's a platform feature that will then automatically create individual database instances for your individual vCluster instances, even based on a template. So it just automatically creates the database and the least permission user possible for that database to interact with a vCluster for its backing store. And then when you delete that vCluster, it automatically cleans up that database instance for you automatically. So that's a really nice way to have high availability data plane outside of the actual Kubernetes cluster itself. So if it worked right as well, this Argo CD instance that's in the API framework project should automatically, I got to sync it. So if I sync it, now it should actually cause it to restart. And then we'll give it a minute, but it should restart. And then it'll spin up 3 replicas for the pod instead of 1 once it restarts. You get the idea.
That's pretty cool. Is the path that most customers take once they start using this? Like they start doing everything in GitHub and like using automation stuff for like the templates and all that, you think? Or
it's a mix. Not everybody is as mature as other people. So some are very mature and GitOps is very important. Others are kind of just getting there.